We begin with Halley's Comet, an ancient ice mountain throwing a bright tail into the dark. Deimos is larger, but still feels like a broken stone captured by Mars. Then comes a body like the Chicxulub impactor, small enough to hide, powerful enough to change Earth. A neutron star core compresses stellar ruin into a sphere that spins like a cosmic engine. Phobos grows in the frame, battered by impacts and slowly falling toward its planet. A stellar black hole can be visually small, yet its gravity edits space around it. Prometheus appears next, shaping Saturn's rings as if gravity were an invisible hand. Hyperion looks fragile and porous, a moon that seems carved from frozen foam. Miranda is stranger still, with cliffs and scars that make it look rebuilt from pieces. Enceladus glows white, venting ocean spray from fractures near its frozen south pole. Vesta is no simple rock. It is a battered worldlet with a mountain-sized wound. Ceres steps up the scale, round enough to become a dwarf planet in the asteroid belt. Charon is so large beside Pluto that the pair almost behaves like a double world. Makemake carries us outward, into the frozen population beyond Neptune. Haumea spins so quickly that its body stretches into a strange, flattened shape. Eris waits farther out, almost Pluto's rival, moving through a colder frontier. Pluto is small, but close up it becomes a complete world of plains, haze, and mountains. Europa follows with an ice crust that may hide a global ocean beneath it. Our moon feels familiar, yet in this latter, it is only the first truly broad disk. Io is larger and alive with volcanoes, flexed by Jupiter until its interior melts. Callisto is an old impact archive, holding scars from the early solar system. Mercury enters as the smallest planet, scorched by a sun that fills its sky. Titan is larger than Mercury, wrapped in orange air and cold hydrocarbon lakes. Ganymede becomes the giant among moons, big enough to hold its own magnetic field. Mars finally feels planetary, a red desert world with extinct rivers and towering volcanoes. Sirius B is Earth-sized, but packed with the mass of a burned-out star. Venus is nearly Earth's twin in size, but its sky is a crushing furnace. Earth appears calm and blue, the only known world where this scale became aware of itself. Kepler-22b hints at larger worlds around other stars, familiar in size but unknown in nature. Neptune expands the frame into deep blue weather, moving faster than sound. Uranus follows, tipped on its side like a planet rolled onto a different rhythm. Saturn is not just large, its rings make it feel like a whole system on display. Jupiter dominates the planets, a storm-wrapped giant that could swallow Earth many times. Proxima Centauri is a star, but compared with what follows, it is only a red ember. Our sun finally takes over, turning every previous planet into a speck beside its furnace. Sirius A shines brighter and larger, a blue-white beacon close enough to rule our night sky. Vega widens the comparison again, spinning rapidly inside a veil of leftover dust. Pollux has left its younger life behind, swelling into an orange giant. Arcturus is larger still, a bright aging star drifting through the solar neighborhood. Aldebaran burns like a red eye, making our sun look suddenly modest. Rigel changes the mood, blue, massive, and brutally bright, a star living fast. The pistol star pushes brightness to an extreme, wrapped in gas it has thrown away. Antares becomes a boiling red supergiant, so swollen that scale starts to feel unreal. Betelgeuse is unstable and immense, breathing out material before its eventual supernova. Mu Cepae deepens the red, a vast star surrounded by the dust of its own decline. VY Canis Majoris is less a neat sphere than a star shedding itself into space. UY Scuti stretches the imagination, with an outer atmosphere too thin to draw cleanly. Stevenson 2-18 marks the edge of stellar size, where a star can engulf whole orbits. Beyond the largest stars in our tour, the scene shifts to structures, beginning with the Kuiper Belt. It is not a wall, but a vast, sparse frontier of frozen leftovers. A feeding black hole turns light itself into a ring, revealing gravity by distortion. TON 618 belongs to another scale, a black hole massive enough to anchor a quasar. Phoenix A pushes the idea farther, where mass is measured in tens of billions of suns. The Ring Nebula is a dying star's outer breath, lit from within like a cosmic lantern. The Boomerang Nebula spreads colder than space around it, a ghostly outflow from an aging star. The Bubble Nebula is a sphere blown by stellar wind into surrounding gas. The Stingray Nebula is smaller but sharper, a young planetary nebula still changing quickly. The Crab Nebula is the expanding wreckage of a star that humans saw explode. Diffuse nebulae widen the canvas, where gas clouds become the raw material of stars. The Orion Nebula is close enough for us to study stellar birth in extraordinary detail. The Rosette Nebula turns young stars into sculptors, clearing a cavity in glowing hydrogen. Carina is more violent, with massive stars carving cliffs and pillars from dust. The Tarantula Nebula is a giant stellar factory, bright enough to be seen in another galaxy. Segway 2 is barely a galaxy, a faint swarm whose hidden matter outweighs its stars. The Small Magellanic Cloud gathers those stars into an irregular companion of the Milky Way. The Large Magellanic Cloud is bigger and richer, close enough to show individual stellar regions. Triangulum reveals the spiral pattern clearly, a whole city of stars seen from above. Then comes our own Milky Way, a barred spiral that contains every familiar night sky. Andromeda is larger and on its way toward us, carrying a trillion-star future collision. IC1101 makes spirals look delicate, spreading a vast elliptical glow across intergalactic space. Galaxies form families, and the local group is ours, bound together by gravity. Alcyonius stretches far beyond its visible stars, with radio lobes spanning millions of light-years. The Virgo Supercluster gathers groups into a regional cosmic landscape of clusters and filaments. Laniakea is our larger gravitational basin, a river system made from galaxies instead of water. The Sloan Great Wall shows structure on a staggering scale, galaxies arranged like a luminous sheet. The Hercules Corona Borealis Great Wall pushes the comparison toward the largest patterns ever proposed. At this scale, the universe stops looking empty and becomes a web. Between the strands are voids, regions so wide that even galaxies become rare. Mass bends the view itself, turning background galaxies into arcs around invisible gravity. The bright matter traces a deeper scaffold, one we infer by the way galaxies move. Expansion is not an explosion into space. It is space itself carrying distances outward. The observable universe is the region whose light has had time to reach us. At the edge of sight lies ancient light from when the universe first became transparent. Every earlier object now nests inside the next, from ice and rock to stars and galaxies. The journey changes what size means. The familiar world is real, but it is not central. Our solar system becomes a point, not because it is small to us, but because the universe is vast. Then the Milky Way becomes a point as clusters and filaments take over the frame. A single galaxy cluster can contain more stars than the mind can comfortably count. Yet most of the volume is darkness, and the islands of light are separated by gulfs. A quasar can shine across those gulfs, powered by matter falling into a black hole. Looking farther out also means looking backward, toward younger galaxies and earlier cosmic time. The same physics repeats at different scales. Gravity gathers, gas collapses, light appears. Even clusters collide, while most stars pass untouched through the enormous spaces between them. A scale ladder is not only about size, it is about learning which forces dominate. On the largest maps, matter gathers into filaments and leaves great hollows behind. Beyond our horizon, there may be more universe, but no signal from it has arrived. The entire ladder remains connected, each scale becoming context for the next larger one. So the final image is not a logo or a label, but a quiet web of light fading into mystery. From that final distance, Earth is still precious, because it is where the universe learned to look back.